Hello. Well, today in week 10, we're going to talk about inheritance, and later next week, we're going to talk about polymorphism. And as well, this week, we'll talk a little bit about lab, the inheritance lab. So we'll get through 10.6 today in the video. So you all know what inheritance is from your family tree. You inherit genes from your parents. In Java, you inherit from a single object. And here's a graphical example. A sedan is a car, and a car is a vehicle. There are other kinds of vehicles. There are other kinds of cars. So here's the UML symbol for it. It's a filled-in arrowhead with a solid line. That means car inherits from vehicle. So from artificial intelligence, we got the phrase is a, and if you can say is a car is a vehicle, or an SUV is a vehicle, or SUV is a car, then it's an inheritance relationship. You can't say a car is a truck. In composition is the has a. So if you have to say has a, like a car has a tire, a car has an engine, then it's not an inheritance, it's composition. So another example is that an insect has various general characteristics. We talk about generalization being the top level, the superclass, and specialization being the subclass. So here's the diagram. And insects all have 6 legs and 2 antennae. So does a bumblebee and a grasshopper, but they have specific attributes. A bumblebee has a stinger, and a grasshopper can jump. So they're also called superclass and subclass, or super inherited relationship. So a specialized object has all of the characteristics of the general object, plus maybe, perhaps, probably additional characteristics. So the keyword we use in Java is extends. The child class extends the parent class. Here's some more terminology. So one advantage of inheritance is that fields and methods from the superclass can be reused without having to be rewritten. We use the keyword extends like the line below. Here's the UML diagram of this latest example, of graded activity, which has a set score, a get score, and a get grade, and a final exam, which is a certain type of graded activity. And it has get points each and get number missed. So here's the code from the general graded activity class and the general and the demo. So grade is a new graded activity, and you can set score and get score and things like that with the methods that are, this is not about inheritance yet, this is just about the general class. And then when you add final exam extends graded activity, so it has all the attributes, set score, the methods score and set score and get grade that graded activity has. So when it calls set score, it uses the method from graded activity, since set score is public, as you can see by the plus in front of set score. So if we were going to use those, we'd see that file exam has this many questions, and how many questions did they miss, did the student miss, and so it would get the grade and get the score and so forth. So exam.getScore and exam.getGrade and exam.getPoints each are all methods that are defined in the superclass. So methods of the superclass that are marked private are not directly accessible by the subclass. That's why we have getters and setters. But they do exist in memory when the subclass is created. But they can only be accessed from the subclass by public methods. Any methods that are marked public are inherited by the subclass and can be directly accessed. So when an instance of the subclass is created, the non-private, and we'll get to several distinguishing elements, the non-private methods are available through the subclass. So setScore is available and getScore is available. Now, constructors are not inherited. So here's a very complicated discussion or description of the constructor situation. So first of all, the superclass default constructor is executed first. So in Superclass 1, here's an example of Superclass 1, and Subclass 1, which extends Superclass 1. So when Subclass 1 is called, it calls the default constructor, the no argument constructor of Superclass 1, always, even if you don't do anything about it. Now, the Superclass default constructor is automatically created, and then it prints it out and returns it. Here's an example of how you might use the superclass's constructor. So this is secret code, very secret. So this is the superclass no-arg constructor, and the secret code is 0. So we're going to call secret code and reset it. And then we're going to call the superclass constructor, the second constructor, the one that's at the bottom of the left, with the superclass with the argument of 10. And that's going to be your secret code. You could also put a setter in another superclass. So here's another example of how you might use that. Suppose you had a rectangle class and a cube class that extends rectangle. So rectangle obviously has 2 dimensions, length and width. Cube also has height. Now rectangle, the length and width are private, but they have setters and getters that are public. So we're going to use those. But we could also set the length, the width, and the height. We'll set the length and width by calling the superclass constructor. Notice the red arrow. And then we set the height separately in cube. So now we got all 3 of those variables set. So here's the UML diagram. Now, here's a difficulty that comes up. If you define a parameterized constructor in the superclass, in other words, a constructor with arguments, then you also have to provide a no-arg constructor. Or the subclasses have to provide a constructor, and the subclasses must call a superclass constructor. So that's all very complicated. So the safe practice is to always provide a no-arg constructor for your superclass, for any class. And notice we did that here. We had a no-arg constructor, which sets length and width to 0. And we have a superclass, a subclass constructor then that has length, width, and height, and it does things the way that we did on the previous, sort of like we did on the previous slide. So the bottom line is always provide a no-arg constructor for your classes, and then you don't have to worry about it for superclasses especially, but also for subclasses. Now we've talked about overloading, which happens when you have the same method name and different parameters. But in a superclass, subclass, in an inheritance relationship, you can have a method with the same signature as the superclass method and it overrides it. It's called method overriding. So the two phrases overloading and overriding are distinct, and you need to understand the differences. So here's an example of curved activity extending graded activity, and it overrides set score. Because it's done differently. So set score is in the subclass as well as the superclass, and it has the same signature. It's the same name and same signature, set score, and whatever S is, but the double. And that is what is considered overriding. So a method signature consists of the name and the parameters in the order that they appear. And so a subclass method overrides a superclass method if it has the same signature as the superclass method. So if you want to call the superclass method, if you've overridden it and you still want to call it, a subclass method can call the overridden superclass method with the super keyword. Super is a lot like this. It says, I want to refer to the superclass, the superclass. This refers to this object, an object in this subclass. But super refers to the overall class and requires that you go to the superclass to get set score in this example. So know the difference between overloading and overriding. Overloading has the same name, different parameters, and it applies just in that same class. Overriding has the same name and a different signature, and it applies in an inheritance relationship. No, overriding has the same name and the same signature, and it applies only in an inheritance relationship. So here are two classes, a superclass and a subclass, and we want to see what the overridden methods are, what the inherited methods are, and what the overloaded methods are. So in the superclass, we have show value with two versions, an integer argument and a string argument. So those are overloaded. In the subclass, we have show value and as an integer and a double. So the double is specific to the subclass because there is none in the superclass. There is no double arg in the superclass. Show value overrides the one in the superclass. So here are the description of the different ones. We override show value, but we also overload both of the show value and with an int and show value with a double argument. Now, if you want to prevent a method from being overridden, you can use the final keyword like it shows here. It'll prevent overriding it in a subclass. Now, there's a third privacy keyword. You're already familiar with public and private, but halfway between public and private is this idea of protected. So you can get access for example, if instead of private fields, if the fields are protected, then a subclass can get access to them directly. So in this example, graded activity 2 and final exam 2, which extends graded activity 2, score is protected. So down toward the bottom right, you see that you can get access to the score of graded activity 2. So it makes it easier. It could make it easier to make it public, but we don't want to do that because that violates encapsulation. It's always better to make fields private and then provide getters to access those fields. So if you're confused, so am I. So here are here's one chart in two sections. If you take the bottom half and slide it over to the right, it's basically 4 elements down the left-hand column, access modifier, and 4 different categories, different situations. And if you follow public across, you'll see that it's accessible everywhere. It's accessible to a subclass inside the same package, all other classes inside the same package, subclass outside the package, all other classes outside the package. Public modifier is accessible everywhere. Private is not accessible anywhere outside the superclass or whatever class you're dealing with. Protected is available to a subclass inside the same package. In fact, it's available to all other classes inside the same package, and it's accessible to a subclass outside the package, but it's not globally accessible to any other class. That's the advantage of protected. So remember this chart, memorize it, and you'll do well to figure it out. So you can derive from another class, and this is an example of a pass-fail exam, extending pass-fail activity, which extends from graded activity, which extends from the superclass object. We'll talk about object in a minute. So here's an example of several classes extending other classes, which extend graded activity at the end. And they all follow those same rules. So here is the UML diagram. And they're often depicted in a class hierarchy like this. Here's the swing components, some of them in a class hierarchy. Now, let's talk about this class called object. Now, unfortunately, I don't know who named it, but this is not an object. This is a class called object. And furthermore, it is the superclass of all other classes in Java. Now, it's normally accessible. It is accessible in the java.lang package because java.lang.star is loaded automatically without saying import. So this class, my class, is derived from object. So there are about a dozen or so methods, and the ones that we're most familiar with are toString and equals that are implemented in the object class. And so if you try to print out an object, a subclass, some class that you've created, and you get gobbledygook, basically a class name and a hash of the memory address, then you know, or I know, that toString hasn't been implemented probably in the subclass. It's only calling the superclass. And the equals method uses equals equals, which we have said several times that equals equals compares the memory address. So it has to be exactly the same object, whereas the equals method is whatever the programmer decides. So all of the methods that we're familiar with, like array list and or string, more exactly, have an equals method. And that equals method does what the original programmer thought was best. So strings equals method compares letter by letter, case sensitive. There's also an equals ignore case and so forth. So the object, if you wonder where that came from, the object class has the toString and the equals methods. Here's some of the other methods, most of which we haven't gotten to yet: hash code and so forth, and finalize. Well, I guess we did talk about finalize, but equals and toString are in that list. Okay, so next video, next week, we'll talk about polymorphism.